Hey, Domipediers! Today we're blasting off into the realm of science fiction to explore the mind-bending concept of warp drives. Imagine traveling to distant stars in a matter of weeks. Warp drives hold the promise of making such interstellar journeys a reality. But are they just the stuff of Star Trek, or could they become the future of space travel? Warp drives work by manipulating the fabric of space-time itself. Think of space-time like a giant trampoline. A massive object, like a star, would create a dip in the trampoline, and that's gravity. Warp drives would create a ripple or warp bubble around a spaceship, essentially compressing space in front of it and expanding space behind it. This wouldn't violate the speed limit within the bubble itself, but it would allow the ship to travel vast distances incredibly fast. The most famous warp drive theory is the Alcubierre drive, proposed by physicist Miguel Alcubierre. The math checks out, but there's a catch. It requires negative energy density, a type of energy that might not even exist. Imagine trying to inflate a balloon with a vacuum cleaner. That's kind of the challenge here. Warp drive research isn't giving up. Physicists are exploring alternative metrics, hoping to find a way to warp space-time without needing negative energy. Some even tinker with the Casimir effect, a quantum phenomenon, to see if it can be harnessed for negative energy generation. Think of it as using the jitters of space to create a tiny bit of negative energy, but scaling it up is a massive hurdle. The Alcubierre drive isn't the only game in town. The Krasnikov tube and the Hawk drive offer alternative approaches, but they still face challenges with exotic matter with weird properties, and stability issues. Imagine trying to ride a warp bubble that keeps collapsing in on itself. Not exactly a smooth ride. Many warp drive theories rely on the exotic matter, a hypothetical type of matter that bends the rules of physics. Think of it as dark matter's wilder cousin. Understanding exotic matter might be the key to unlocking warp drives, but so far, it remains elusive. A theory of quantum gravity, which would combine the bizarre world of quantum mechanics with the vastness of general relativity, could be the game changer. Imagine finally having a complete picture of how gravity works on the tiniest scales. This might shed light on manipulating space-time and exotic matter, bringing warp drives closer to reality. Warp drives are far from becoming a reality, but the journey of exploring them is pushing the boundaries of physics. Even if we can't travel faster than light, the research might lead to revolutionary new propulsion technologies or a deeper understanding of space-time. So, buckle up, because the future of space travel might be stranger than fiction.